Okay. Good morning, all. Are you able to hear my voice? At least one yes or raise
Yes,
your
sir.
hand.
Good
Okay,
morning,
fine.
sir.
Okay, okay. Good morning. Good morning. I'll continue. I will go very slow. Let others can also join in between. Sorry, I made your Sunday to be occupied with the class, but there is no other choice. So far, we learned the some programming, basic programming skills actually, and also the way the programs can be done. Somebody is participating. Okay, now you can listen. If you want to unmute yourself, just raise your hand. I will give permission. Otherwise, without knowingly, they are unmuting. Uh, this is the thing. Actually, it's going well. You can drop message also because when I'm in class, I may not be able to see the other tasks. Mathematical methods of physics and C programming also involves with some programming skills actually. With the numerical techniques, what it was used. Yesterday I shown before winding up the class. Numerical techniques are nothing but the techniques used to solve any problems, either physical problem. Physical problem is either from physics background or in general science background, or mathematical problems, or engineering problems, or means the problems which are related to the disciplines they can call of either from physics or engineering or science or even chemistry also can use. There is no doubt, including the mathematics. The techniques are employed are the one with the numerical one. In the sense, by making use of the number gaming, by making use of the number systems, by making use of the techniques which were involved in the number system, one can develop. Numerical techniques, maybe using several languages you can use. These are the techniques can be employed to solve any of the problems, physical problems they can call. For example, solutions to find the solution of any of the algebraic equations. Linear algebraic they are putting because making it as a simpler way using the matrix method. This is not there in your syllabus, but for your continuity you require. In the sense, not there in the sense not to read. Unless you solve some equations using the matrix where you added up or multiplied the two matrices in your computer lab. Okay, this is the one of the essential things. Then solution for the transcendental equations or transcendental in the sense any kind of an equations apart from linear equations, apart from nonlinear equations, if it involves with the power, if it involves with the exponential, if it involves with the logarithmic, or even if it involves with the trigonometric functions are known as the transcendental equations. There are two techniques to solve. One is the bisection method, okay, another one is the Newton-Raphson method. Maybe I will try to discuss only these two methods for today. The curve fitting by least square fit method, you are well aware. Numerical integrations, it is called numerical integrations, not the integration by some other technique. Integration by, not by first order principle, second order principle of that kind. Okay. it is by either trapezoid or maybe Simpsons. Then later, numerical solutions of differential equations by Euler and Jacobi method. Finally, we're finding the least square fit using the Lagrange's interpolation technique matches with the curve fitting by least square fit method. They are one and the same thing, but one and the same thing in the sense in terms of some technique actually. Okay, you can find the least square fit method using the interpolation technique. How one can find actually that we'll try to see that. So let us see that. You just be there. Anyhow, I will share these things. This is also streamlined and on YouTube actually. You can watch whenever you wish. Numerical techniques using the C language, solution of linear algebraic equations using the matrix method. You can solve any equations like y is equal to mx plus c, one simple linear equation. If intercept is 0, then y becomes m times x. Okay, how that x varies, the y will also vary depending on the slope. If both are exactly linear in the sense slope becomes 1, then there is a mirror image between x and y axis. If it is 2 times x, maybe the line will move towards the y. If it becomes 3 times x, line will move towards y. If it is exactly the same straight line, then it should be on the same case actually. Okay. One method is the Gauss elimination method they can call Navier-Gauss elimination. Here in this matrix, a simple matrix actually, a method to solve the simultaneous linear equations which are in the form of A times x is equal to C. A is a matrix, x are the variables. X are the variables, or A is the matrix elements you can call. Either you can call 2 cross 2 matrix, 3 cross 3 matrix, 4 cross 4 matrix, or n cross n matrix, depending on that is the order of the matrix you can call. X is the variable like x1, x2, x3, and C are the constants on the right hand side actually. In the sense, matrix A denotes the elements which are corresponding to the A1, A2, A3 are known as the first row, B1, B2, B3 are known as the second row, C1, C2, C3 are known as the third row, or sometimes they will also call it a different way that I will explain in the next slide. There are 2 steps to solve this equation, this set of equation they can call. How they will do? One is the forward elimination method or backward substitution method. Means not or both. One is that you have to eliminate some of the elements where you are making the matrix into an upper triangular matrix or lower triangular matrix. Depending on that, one can proceed that how one can able to estimate the solutions. Means forward elimination in the sense you are going eliminating or making the elements below the principal diagonal elements as 0 elements. In the sense the values of elements are 0. If that is the case, if you multiply, then you will get the last variable first actually, like x to the power of n, maybe x to the power of n minus 1, x to the power of n minus 2, maybe x3, x2, x1 of that kind by backward substitution method or back substitution method. How it will happen, you'll see that. The goal of forward elimination is to transfer the coefficients of matrix into an upper triangular matrix. Upper triangular matrix is nothing but this is the principal diagonal element. Principal diagonal element. Okay, principal diagonal means above that principal diagonal elements, the element should have the values. Below that, the zeros. Because of this 0, you may not find the last element is only x3 here actually. Okay, and x2, x1, coefficient of x2, x1 are 0. In the first one, the coefficient of x1 is there, x2 is there, x3 is there, x3 is there, it is having all. Means this is the one where you are converting that into the 0 elements below the principal diagonal element by some technique. Assume that this is the matrix diagonal, coefficient of the matrix. Because if elements exist above the principal diagonal element, it is called upper triangular elements. For example, if it is a mirror image, if the elements above that are 0, if values exist below that, then it is called the lower triangular matrix. Wherever the values are there, that side you can call it as either lower triangular or upper triangular matrix. Here, this one example I have taken. You can choose any of those things actually. Okay. If you convert this into forward elimination process, means all the elements below. First step is that the below first element should be 0, then second element should be 0. If it is 3 cross 3, then third element should be 0 of that kind actually. Means this is how it has to happen actually. What happens while you convert, the first value remains same. The second value is taken in such a way that the first row minus second row with some coefficients if you multiply, then you will get the second row as a 0. If that is the case, the value of the coefficients will not change, eigenvalues will not change, and it remains as such actually. Because of that, what will happen actually? Assume that a set of equations, how many equations are there? Let it be n equations and n unknowns. I will move to the first. If you know, if there are three coefficients, you need three equations. If there are two coefficients, you need two equations. If there are four coefficients, you need four equations. Means if there are three variables, if you are having four equations, you can write actually, it is overestimated. If four variables are there, if you are able to formulate only two equations, that is the two equations of that kind, it is underestimated. If the number of equations matches with the number of the variables, then it is said to be an ideal condition for a matrix to solve to get the solution for any variable of that kind. B is a set of n equations, okay, or maybe three equations are required to solve three unknown quantities. Which are unknown quantities? X1, X2, X3 are the unknown quantities, like including Xn. Coefficients A11 in first row, A12 is the second element of the first row, A13 is the third element of the first row, are the coefficients of X1. A11 is the coefficient of X1, A12 is the coefficient of X2, A13 is the coefficient of X3 in the first row. Okay, first row. Then that must be equal to a constant known as the B1. Second equation also can arrive like that. A21 of X1, A22 of X2, A23 of X3 almost equal to B2. Means if you solve like that, an1 x1, an2 x2 to the bn. N minus 1 steps for a forward elimination procedure one has to solve. If that is the case, what normally you do? Step 1 is that equation 2 in the sense, multiply the coefficient here a21, multiply by a11 and divide by a21. Okay, for the second equation. Multiply by a21, divide by a11. What will happen with the first equation? For equation 2, divide equation 1 by a111 and multiply by a21 here, these two. Okay, what you will get? This is the a21, this is a11 gets cancelled, a21 over a12 of a12. This is the precision what you learned from your earlier days. If you subtract those two equations, you will find another variable like a22 prime. What happens to the a21 prime? It is 0, 0. Then to a2n prime of b2 equals to 0. Okay. Still, if you continue, this is how that equation. Repeat this procedure for the remaining equations to reduce the set of equations such as a11 only first element will be there, a21 is 0, a31 is 0, a is 0. Then if you repeat the same thing for the till second, a31 and a32 are 0. Here a21 is 0, a21 is 0. See, x1, x2 are not non-zeros. Okay, only coefficients will reduce to 0. Okay, a21 is 0. Here a31 and a32 are zeros. If you go for further, you will get a matrix in such a way only principal diagonal elements exist. Below the principal diagonal elements are the coefficients with 0 values. If that is the case, what you are expecting at the end of the n minus 1 forward elimination steps, the system of equations will look like this. Means an to the power of n minus 1 of xn must be equal to bn of n minus 1. You easily estimate the coefficient xn value. Xn is nothing but the ratio of b to ann to the power of n minus 1. bn to the power of n minus 1 to the n. If once you know ann, you substitute that ann in the previous steps, you will get an minus 2, an minus 3, like a3, a2, a1 at the end actually. This is a simple step. Matrix form at the end will be like this actually. Here, see that all of them are zeros and rest of them you will find actually. Means by substituting what will happen? You will get the values. Value of x3 here in this case is the 0.735 over 0.7. If once you know the x3, substitute here actually you'll get x2. If you know x1 and x2, it is easier for you to estimate the x1 by backward substitution method or back substitution method. Examples of a system of three set of equations is three equations is like this. Okay, back substitution starting equation with this variable. This is the ratio what I told. This is the one for the rest of them. The Navy gas elimination what you took is with the example will solve actually. I see. Okay. The examples are the better tools way that can convince you in a better way apart from going with the theory. Theory should know how to apply the theory to obtain the solutions. The upward velocity of a rocket is given at three different times. See, a rocket is the one which can carry the satellite and put the satellite into the desired orbit for low Earth orbits or any middle Earth orbits. But for some satellites can be taken even up to the geostationary. Some satellites can also be taken to the other planets to a great extent. Since I am with the background of the atmospheric and space physics, I love the examples from physics, space physics background, where you are also learning the same thing in your classical mechanics or that very section. A simple equation with classical mechanics. Upward velocity, how that velocity changes with time, one should know that. Here they have given in the table. See, after 5 seconds from the launch, the velocity acquired by the satellite, rocket is 106.8 meter per second. Okay, fine, no issue. At the time of 8 seconds, okay, after 7 seconds, completion of 7 seconds, 177, it is shooting up, fine. At 12 seconds, it is about 279.2 or roughly 280 meter per second. No issue, good. The velocity data, what it is represented is approximated by a polynomial. How you can do that? You know from your basic physics. Velocity at any given time or at any given amount of time must be equal to a1 times t square plus a2 times t plus a3. There are three coefficients, a1, a2, a3 of that kind. But this equation is valid with a time interval of 5 to 12 only. You are not supposed to expect what must be the velocity before 5 seconds. We don't know. We don't have a data. What must be the velocity or what will be the velocity after 12 seconds also we don't know. This is the expression. It is not a general expression. It is, of course, maybe a general expression written or general expression arrived for a time limit between 5 to 12 seconds. If I want to know what must be the velocity at when time t is equal to 6 seconds, within this interval, I can find either 6 seconds, 7 seconds, 9 seconds, 11 seconds, or fraction of 11.8 seconds, doesn't matter. Any value between 5 to 12, I can estimate. We'll see that how it should be done. Velocity is equal to same case. You convert that into the matrix. T1 square plus T2 square plus T1 square plus T2 square T3 square. T1, this is the first variable. T1, T2, T3 is the one. Of A1, A2, A3 variable, V1, V2, V3 is the velocity, that is nothing but constant. What the data they have given? This is the same table I used, okay, here. Okay, if you substitute here using the table data, when time A1, A2, A3, when time t is equal to some 25, 5 seconds, 5 square, 25 square plus 5t plus constant A1. Okay, here how they are getting actually, this is a second. Second is that 8 seconds. At 8 seconds, we know the value, 8 seconds. Because why we are getting 8 seconds? Because we know that RHS value. Okay, 177.2. At 8 seconds, 8 times t square, 64, 8 time. Then at 12t, we know, okay, these three variables. This is the coefficient. The same thing I took it for the first example. This is the matrix. You can convert forward elimination and back substitution method. With forward elimination, number of steps for forward elimination is n minus 1, that is equal to 3 minus 1. Only 2 steps are required. If you do this, okay, this is one simple thing I'm sharing you. You will get to the end with backward substitution. 0.7 over 0.76 over 0.7 about A3 value, then A2 value, then A1 value. After getting A1, A2, A3 value, what you will do? You know that this is the matrix A1, A2, A3. If you substitute in the equation A1, A2, A3, the polynomial that passes through the three data sets is that point, same thing of t is t square plus t2 ty. If you want to estimate, this is the equation in fact. If you want to estimate what must be the speed at 6, take at that 6 second, it should be 129.686 meter per second. Very good. Very good. The speed should be in between actually T1 and T2, T3. You got it. This is 1 second. This is see 129 or 130. Say that here between these two it should be there. 130 is there at the 6th second, maybe approximating near to the 5th second. It is shooting up. It is gaining the speed actually. This is one of the beautiful technique for solving the system of the equations or system of the linear equations using the matrix method. If you convert that any set of equations, system of equations into a matrix, it is easier to solve. We should have two techniques to solve the transcendental equations, bisection and Newton-Raphson method. One technique is first bisection method is a simpler technique actually. Okay, our techniques are simple if you learn well. Relatively simpler compared to the Newton-Raphson means it does not involve much steps. There are limitations. There are advantages also over one step with another step. Let us see that how it works. Bisection, the meaning is that we can bisect, we can make into two halves. Once you make into two halves, with those values, if you substitute into the equations, I will show you one after the other. Just I shown yesterday here, something on x-axis, something on y-axis. The value of the function at a point A is known as the function at A. If it is greater than 0, certainly it lies above. The value of the function at B, if it is at a point below the line, solid line on x-axis, the value of the function is negative. At somewhere middle point, the middle point is that A plus B over 2. A plus B over 2 is the value of the C. What must be the value of the function at C? We should know. We have to estimate. We don't know. Sometimes it may be an above or it may be below. That depends on the function. F of C is greater than 0. If that is the case, this is the how the function. First we should draw the line actually, not an issue. This is the solid line is the function. Solid line is the function. Let us choose some value A, wherever. This is the lower limit they can call. Estimate the value of the function at A, need not be at the peak. If it is greater than 0, lies somewhere here. Anyway, up to this point, let's choose some point B, where the value of f of B is less than 0. If we take the product of these two, f of A and f of B, certainly the value should be the negative. Value should be negative. The solution lies in between. If the product is if the product of the function at the two values, if it is negative, then certainly the solution lies in between. Means to say that at the midpoint or at that point actually the function intersects the x-axis. Means what you mean by solution of an equation? Solution of an equation is nothing but the value of the function at a given value of x has to meet the x-axis. At the f of x, y is equal to 0, the value of y is equal to 0 for a given value of f of x. Function f of x has to tends to 0. F of x is nothing but the value of y. Value of y that must tends to 0 for a given value of the x. Our intention is to estimate what is the possible value of the x actually. This is in this method, it is a guaranteed it will converge to a root if one exists within the bracket. Means if we expect the solution between these two with a condition f of A and f of B, if the product of f of A and f of B is less than 0, certainly solution exists. Okay, means the solution is guaranteed and it converges to the solution. Fine. At A is equal to C here, we are approaching the solution compared to some other point. See that still if you take, if B is equal to C, still the second value, how the algorithm can be written for this type of function? You see, simple algorithm given these programs will work, these numerical programs will work in next semester in your computer lab. Okay, it is an unfortunate that there is a small mismatch between the laboratory and the theory part. Okay, at that time also we will try to explain you in detail, no doubt. But in theory, you remember, simple program is that given the value of a and b such that f of a and f of b should be less than 0, means what I explained, function at a and function b should be product of the function at a is positive, product of the function at b is negative. But if you take the product of those two, it should be the less than 0. Then one can able to estimate the error in such a way, c is equal to a plus b by 2. Right, if f of c is greater than the error and f of a, f of c is less than 0, root in the left half where b is equal to c. Else, a is equal to c is the root. The two simple solution here. If f of a and f of b is less than 0, then root lies between a and c. Okay, here somewhere. If it is greater than 0, then root lies between c and b. That is the only the criteria what they told. Means if error is greater than 0, f of a and f of c is less than 0, root is in the left, that is b is equal to c here. B is equal to c. Okay. If not, a is equal to c, you can take actually, it will continue. Find the new point. Basis of the bisection method is in such a way, an equation with f of x is equal to 0 means at a given value of x, function has to be the x-axis, where f of x is a real and continuous function. Okay, it is has at least one root between the lower limit and upper limit of the x1, or even sometimes x1 can also be called as an x lambda. If f of x1 and f of x lower limit xl and f of x u is less than 0, see that is one root. At least one root exists between the 2 points if the function is real and it is also continuous and changing sign from positive to the negative sign between the two. Let us choose the function of this kind. Here also same case, the function changes. Okay, this is upper limit, this is the lower limit. The function changes from positive to value if the function does not change the sign, because if you take the product actually, but roots in the equation may exist, because see that here it intersects at one point, here it intersects at 2 point actually. This is the lacuna. If such type of limits if you are expecting, and if the function cuts or if the function intersects more than one time the x-axis, even though roots exist, even though solution exists, but this technique will not identify the solution. This is a drawback. If the function f of x does not change the sign between the 2 points, you want to see that here does not change, but roots exist. Here lower limit, if it takes such values does not exist, there may not be any roots for the equation between the 2 points. Even sometimes function changes the sign between the 2 points, here to here changes, but how many? More than once. Here 1, 2, 3. Then it is difficult also to estimate the solution. If such type of thing, exact solution is difficult because it is a 3 values are there. Okay. Algorithms for bisection method is that choose one lower limit, choose one upper limit, any value. Either you can choose here top, bottom also any value, and it is only by guess. You can make a guess. You might have made a guess with multiple choice questions several times where the answers exactly matches with the knowledge what you acquired so far. Sometimes it may go wrong because the question may be framed in such a way to deviate you. It is not cheat, to deviate you from your thoughts and making you a precise answer with one single concept. That concept, if you are not following, you may not arrive for the exact solutions. But in all competitive examinations, the multiple choice questions are the one where all options are the answers for a question, but not the exact answer, but not the much relevant answer they can call it. If f of lambda function at f of x lambda and f function at f of upper xu, if it is less than 0, or in other words, if f of x changes its sign between the two interval, certainly root exists. If that is the case, then at that midpoint, what will happen? Take the midpoint between these two. Okay, you will get somewhere here. Means to say between x lambda and xm, if you take function at x lambda and f of xm, if you take the product, certainly the values are too negative, it becomes positive. Root does not lie between here. Root lies between xm and xu. Estimate the xm. Means f of x1 and f of xl and xm. If it is less than 0, root lies between lambda and xm. Here in this case, between these two it is not happening. Okay. Then if x1 and xm is greater than 0, then the root lies between xm and xu. That is, x lambda is equal to xm, fine. Xu is equal to xu as such remains. If f of x lambda and xm is 0, exactly 0, then the root is the xm. If it is less than 0, root lies between these two. If it is greater than 0, the right side of it. If it is exactly 0, root lies exactly at the point of the xm. Stop the algorithm. Then if this is true, can find the new estimate from this method. Xm is equal to x lambda plus xu over 2. Find the absolute error. You can minimize the error from each steps if you are estimating new error and old, and over the new if you estimate the x old to the x new, the difference should be minimal. If the difference is minimal, it becomes exactly 100%. I will have the same case actually here with another example. Here what's happening? Assume a ball floating in water. No doubt, ball has to float. And floating ball has a specific gravity of 0.6. Okay. Specific gravity is nothing but the gravity at which it can be held in the media like fluid because of its buoyancy force and also the mass or the weight of an object. And it has a radius about 5.5 centimeter. Radius, they are saying that about a diameter of about 11 centimeter. You are asked to, it is find the depth to which the ball is submerged when floating in the water. It is on a graphical representation shown. Maybe more than 50% is floating, less than 50% is submerged in the water. Okay? How much is the depth of ball which was sink inside the water? That we have to estimate. The data given is that the equation you can write given to the depth which ball is submerged under the water is given by. This is the equation. Don't worry, we will provide you an equation. Okay. X3, of course, you can also what we can call generate or formulate the equations by a trial and error method. X cube minus 0.165 x squared plus 3.99 to 10 to the power of minus 4 is equal to 0. Or you can say that this must be equal to minus this value. What is our objective? By making use of the bisection method, finding the roots of an equations to find the depth x to which the ball is submerged under the water. Well, here you can go for any iterations. Let it be 3 iterations to estimate the root of the above equation. Then we will go for the solution. Find the absolute relative errors also at the end of each iteration and the number of significant digits at least correct to the end of each iteration. Continue. Here, from the physics of the problem where you are learning your masters, the ball would be submerged between the two limits. If it is not merged entirely, it can float. One limit is 0. Another limit is that entirely it can submerge 2 times r, or completely it can submerge, not well deeper. This is the maximum. This is the lower limit. This is an upper limit. Or this is the minimum possible values for submerge. It can float the entire thing. It can entirely submerge, where r is the radius of the ball. If this is the case, what happens? The limit is that x can vary between, this is the x can vary from 0 to the 2r. Value of r, radius, that is the value of r lies between, the value of the submerged will lies between 0 to 0.11. Okay. If this is the case, how one has to find the solution? To aid this in understanding of how this method works to find the root of an equation, the graph of f of x is shown on the right side. What they have made is that equation they have provided, substitute the values of x 0 and substitute the value of the x as 0.111. Okay, x as 0.11 here. Okay, and in between you go on having the values of the x, maybe 0.01, 0.02, 0.03, 0.1, 0.11 of that kind. Then you plot. You will have a tabulated value. Y is equal to f of x. Y is equal to f of x. How that function changes with time, with the what you can call x value. X value means that is the radius of the earth actually. Okay, this is how the function is appearing. By seeing the function, even without estimating the solution, without learning the technique, one can estimate that, one can know that where it intersects. Whether you can draw a straight line, that is a different issue. If you are drawing a curved line with many points, actually, these are the points where this is the curve where it has moved with the points actually. Okay, 0.06 is somewhat 662, 1062 is the solution actually. We'll check how it works actually. Let us assume this is the lower limit, this is the upper limit. Check if the function changes its sign between these two, x1 and xn. This is 3.99, fine. First one, no doubt. Second one, upper limit with negative. If you take the product of these two, certainly it should be the negative, that is less than 0. We are sure that there is a solution in between zero point 0 and 0.11. If you continue, see that this is the 0 value, green color, and this is the 0.11 at the yellow color. Certainly the function lies between these two. Fine. What is that? That is the function. Okay, it is a demonstration actually. Still, if you go, first one is XL lower and upper limit. You take it to two hours. That is the average actually. They can call midpoint also. You can call 0.55. Now we estimate between 0.55 and 0.11 or between 0 and 0.55. But let us see between these 0 and 0.55 at okay 0.55. This is the value at 0.55. Between 0 and 0.55, the solution is greater than 0. Product of the value of the function at the lower and upper limit between 0 and 0.55 is greater than 0 says that solution does not exist between these 2 points. Hence, the root is bracketed between the xm middle point 0.55 and 0.11. So, the lower upper limit of the new bracket is 0.55 and the 0.11. If we estimate the error here, whatever I shown in the formula, the error also comes into the picture. This is a new value. New value is the blue color. Okay, new estimated root. Okay, at the blue color 0.55 here. Still, it is value the function is positive, and root does not lie between green and blue. The root lies between blue and yellow. Yellow means because the product lies this should be less than 0. If you estimate that 0.55 and 0.11, still we are going narrow about 0.825. Try to estimate the value of the function at 0.0825. The value of the function at 0.0825 is negative. Negative, certainly root lies between 0.055 and 0.0825. See that blue color is the midpoint again actually 0.055 to about 0.825. Between these two, between blue and yellow, no choice of the function. The function exists. Function has to meet the x-axis. Root lies between green and blue. You are dividing and approaching the solution at any time. Now the error involved is 33% here. None of the significant digits are at least corrected to the estimated root of 0.0825 because same case. Okay, because the absolute relative error is greater than 5%. See, if that is the case, if you estimate between 0.0685 lies between that, you will get the new x value, okay, and the earlier one. See that still it is closure. If you repeat, this third iteration is over. The first year 33% error. Next step, you are getting an error of 20%. Error has come down actually. Still, none of the digits are at least corrected to the in the estimated accuracy. We will proceed actually here. Yeah, it is a beautiful table. You spend some amount of time in estimating, you will get the same values. At least Mahalingaya, I hope you will do that and bring that estimated solutions to me tomorrow, okay, to the class. Tomorrow or day after tomorrow. Even others also, okay. Here with 0 lower limit, this is the upper limit, the midpoint is here. There is no estimation, value of the function is somewhere here. This is the new root between these two. Error is 33%, function is negative. Okay, wherever negative goes, you can continue. Here, the two values, the error is 20%, the function is negative. If the product of the function between these two intervals, okay, between 0.55 to 0.6785, root does not lies between these two, 11%. Still, error is coming down as the number of iterations goes up. Okay, the error is coming down. The solution is that starting from this 0.61, 65, 63, oscillation between 62 actually, 62, 623, 6252, 6241. The error is less than 0.1. Okay, then we can stop at that point actually. Means the value of the solution for this function is about 0.062. 0.062, and another case is that you are having a concurrence values for the third decimal here actually. Up to 4 decimal you can go. So up to after 3 iterations. After 3 iterations you stop because it has come to that level actually. Means to say that is a thing. Hence, the number of the significant digits at least corrected to by the largest digit is so much. Okay, means 0.06241 at the end of the 10th iteration is 2. You can stop at this point. The advantage of this method is that always it is convergent, means always it approaches to the solution. The root brackets, root means that is the solution, root bracket gets solved each iteration and solution is guaranteed. The drawback is that it converges very slowly. We don't want a slow process. We want very fast. Okay. If one of the initial gases is close to the root, then convergence becomes slower. While choose the limit very far away, then immediately it converges. If you are choosing very close, nearer, it is very difficult for you to go upward. What happens if you are choosing one of the root at near point? Actually, we may not be aware, but it will take the diversions first, then it will converge. If their roots are very far away, immediately both roots will get converged to the mid value, and the root it is you are getting the root in a very perfect manner. See that. For example, if a function f of x is such that it just touches the x-axis, it will be unable to find the lower and upper guess. If this is a case, you can't make a guess actually. The f of x, f of a and f of b should be negative. It should intersect and should be in opposite side. If the function is of this kind, but like f of x is equal to x square, it is difficult to find the solution by bisection method. Like if the function lies between like 1 over x of this kind, maybe 1 over minus x of this kind, certainly difficult. Root does not exist. Even though function changes its sign. See that here to here it changes. Okay. Then Newton-Raphson method will help actually. How that Newton-Raphson method works, we'll see here. The same function. Newton-Raphson method is a method to find the solution of any of the functions. Okay. Function is in such a way, this is the function. It is having values both. Instead of making the two guess, you can make only one guess actually. This is the value of the xi for a given function. This is the value of the function at f of xi. F of xi. The value of the new values of the function can be estimated in such a way. Xi plus 1 should be xi, the value of xi, minus the value of the function at xi over derivative of the function at xi. Derivative of the function is nothing but the tangent drawn to that function. Tangent drawn to that function. If you draw a tangent to this function, okay, at xi, this tangential line meets the x-axis at some point. That is the new value of the new value of the function. Using this xi plus 1, this is the new xi plus 1 here. Xi plus 1 can be xi plus 2 can be estimated in such a way. Xi plus 2 is equal to xi plus 1 minus value of the function at xi plus 1 over the value of the function at derivative of the function at xi plus 1. Xi plus 1. Then you will get the new value xi plus 2. You will see in detail actually how it has to happen. Tan alpha here in this case is the derivative. This becomes a times b over a times c, a times c, a times c. Or derivative of the function at xi here. This is the function, this is the derivative at this point. Derivative at this point should be value of the function at xi over xi minus xi plus 1. The new point where it intersects. Or take this function in such a way, xi minus xi plus 1 is equal to derivative ratio of the value of the function at xi to the ratio of the value of the function at ratio of the value of the function with the derivative at f prime of xi. Algorithm 1, how you get right? Step 1, evaluate the derivative. Use the initial guess, only one guess is required to estimate the new value of the root. Xi plus 1 is equal to xi, you know, value of the function at xi and value of the function at its derivative. If you do that, you will get the new value. Always xi minus xi plus 1 minus xi over xi plus 1 gives you the error. The error should come down. The same step what we followed for the last one. If you take the same example from this method, same equation, xi, let us choose some value. I'm repeating this thing. Let us choose the derivative f prime of x f of x is like this. F prime is, that is 3 times x square minus 2 times this value of x is equal to 0. This is a constant. Let us assume that the initial guess of the root is at when f of x is equal to 0. Okay, this is a reasonable guess. What should be the value of the f of the x? Let us assume that initial guess of the root. Okay, reasonable guess is x naught is equal to 0.95 meter, because x is equal to 0 and 0.11 meter are not good guess. Okay, let us take some midway here. As the extremes values of the depth would be at a 0 and diameter should be about 0.11, some mid value they have chosen. If that is the case, what will happen? X1, if you want to estimate, x0 is 0.5, not 5. F x0 0.05, substitute the same thing in the equation. Here, f of x you know, f prime of x you know, value of the f prime of x is this value. You will get the value of 0.062 as the new estimate. X0 is 0.05, x1 is 0.06242. See that because of this tangent line function, you know that is in red color. X0 where exactly meets earlier one, current root. X1 is the new root with this one. Okay, tangent line is the drawn in blue color. Where tangent meets, you can estimate. Error is 20%. Earlier case we got 33% first error. Second percent you got 22%. 22%. If you go with the same step for second step, see that lines are matching much, and error is 0.07. Immediately it has converged from 19 to 0.07%. Okay, means to say that the Newton-Raphson method converges faster compared to the bisection method. This is the third iteration. Go for the error. See, there is no discrimination between red and blue line. They are overlapping, including green. Exactly matches. Error is 0. My God. Means certainly we can adopt. Means certainly the number of the significant digits, at least to the correct of these 4, as only 4 decimals here. 1, 2, 3, 4 decimals. See, this is the difference between them is the same. Okay, digits are carried throughout all the calculations. Means converges very fast. It is quadratic convergence. If it converges. If you are making a case where the function is not converging, we will never find the solution. It requires only one case. Okay, my God. Even with one case, we will be deviated. If you are making a 2 case in earlier bisection, certainly there are more chances of not getting the solution out of it. This is one of the best methods to obtain the solution of the linear equation. Transcendental equations. Here, this is also a drawback. Some drawbacks we'll see that. Divergence at inflection points. Inflection is a selection of the initial guess if it is a wrong, or number of iteration values of the root that is very close to the inflection point of the function may start diverging away from the root. 0. What happens here? If the equation is like this, f of x is equal to x minus 1 to the cube plus 0.512 is equal to 0, x I is nothing but this is the new one. Table here shows that how it converges. See that. First root, second root, third root. Once you are moving up, once you are coming down. Once you are moving up, once you are coming down. If you draw a tangent, tangent is exactly matches with the x-axis. You will never find the solution. Divergence at inflection point. Here, what you are expecting actually, you may not find the Newton-Raphson method a better tool. If you go with the bisection method, at least you will find one value. That is exactly fine actually. Okay. Say drawbacks. Division. If it is divisible by 0, for example, somewhere. This is an upper extreme cases. If it is divisible by 0, division by 0 for the equation, okay, xi minus 1, x naught is equal to 0.2, then denominator will be equal to 0 if it is a pitfall of the division by 0. Means if such type of, because f prime x becomes 0, then derivative is 0, then it is a tough task. Means this is not the one. Sometimes if it is an oscillator, for example, see, it is initial guess. You will get here. Second guess, first here you will get. Second you will get here. Third you will get here. Fourth one you will get here. Sixth one you will get here. If it is an oscillation of this kind, certainly Newton-Raphson method is not a good tool. Oscillations near local maxima, for example, under the minima in Newton-Raphson method will not give the solution. Assume that first one is about 300% error. Then it is only an oscillation actually. Error will never truncate. Means if function is of such kind of a function, both Newton-Raphson method is not a better method for that. And even sometimes root jumping they can call. See that root somewhere, first root is somewhere here, second root is jumping from here to here, third root is somewhere here, but that sine type of an sinusoidal or cosine functions, this is not the right way. Here I'm showing that values are not much. With pictorial representation, you can show this is jumping. This is the technique actually. We'll try. Still time is there, no issue. But the curve fitting method, you drawn so many equations earlier. So many lines you put. Normally you plot a y-axis against the x and then try to connect the points between the lines. If you want to make one straight line to estimate the slope or way you want to see where it converges actually, certainly draw it. Curve fitting is nothing but you can do that in any technique method. Least square fit method is one method out of that. For estimating the linear regression, sometimes they will also call it as the correlation method. What is the regression? Regression is nothing but finding the correlation between an independent and dependent parameter, or that dependent parameter depends on, or how far dependent parameter is agreed with the independent in such a way the correlation should be maximum of 100%, minimum of 0%. If it is highly correlated, coefficient becomes 1. If it is less correlated, coefficient becomes near to the 0. No correlation is minimal. If it is the correlation is negative values, you can call it as an anti-correlation or an inverse correlation. In the sense, if something is increasing, x is increasing, y should also increase if it is having a correlation. If instead of increasing, if y decreases, it is moving in a reverse order, it is moving in a negative axis, it is moving in a reverse trend, then you can say that it is anti-correlated. Yeah, it happens actually. If for a given n points, for example, these are the points which are shown in dotted one, like x1, y1 is first point, x2, y2 is the second point, x3, y3 is the second point. X and yn is the nth point, need not be last point, nth point. To fit this, the best fit line shows that it is not a linear, but best fit line moves across the points, need not touching any of the point. Don't try to always connect the points actually. The best fit line is generally based on minimizing the sum of the squares of the residentials. Minimizing the sum of the squares of the residential. For example, r square value, deviation, r square, r1 square minus r2 square, r3 square plus r4 square. If you take, the summation is 0, then that is the best one. Residential points are taken in such a way that the value of the function minus the derivative of the function if you choose at that f of xi, what must be the value? Means sum of the square of the residentials. Yi is the function, y is the function, yi is the value of the function at any given time. If you take actually, this should be the minimal value. We'll see that how it has to happen. Linear regression goes in such a way. These are the points x1, y1, x2, y2, x3, y3 of that kind. Minimizing means, let us take some of the errors epsilon I. Criteria is that yi minus a0 plus a1 x1. Yi is minus a1, a0 minus a1 x1 is the first line. Okay. Now, given the data sets, we will go with one example. See that. This is the data points. 2, 4 somewhere here. 2, 6, third point. 3, 6, 3, 8. See that there is a commonality between the 2, 3 and 2, 6. 3, 6 and 3, 8. Okay. Y-axis also one point is common. 3, 6 and 2, 6 and 3, 6. This is the table. 2 for a corresponding to 4 is the value. For a corresponding 3, 6 is the value of that kind. How to plot? Can I connect between these two lines? Can I connect these two lines? Or can I connect these two lines? Can I connect between this line? There are possibilities. Which is the best line? If I do like this, y is equal to 4x minus 4 as the regression curve. Residues at each point of the regression model as shown here. Y predicted is 4, but y minus y predicted should be 0. Fine. Okay. If x is equal to 2, y is equal to the same case. If x is equal to 3, what should be there? Minus 2. See that sigma I should be 0. Minus 2 plus 2 gets cancelled because we are not considering these 2 points. Using y is equal to 6 as the regression curve, for example, here y is equal to this equation, y is equal to 6 as the regression curve. See that all are moving. This is also possibility of the straight line. Okay. Another case, for both regression models, y is equal to 4x minus 4 and y is equal to 6. The error involved is 0, but they are not the best fit lines. The sum of the residentials is as small as possible, that is 0, but the regression model is not an unique one. Hence, the above criteria of choosing this, minimizing the sum of the residentials, is a bad criteria. Will minimizing this modulus of this will work any better? You try. Instead of doing only summation, let us choose modulus. It is 4 in first case. It is also 4 in second case. No, it will not be. The sum of the errors has been made as small as possible, but the regression model is not unique. This is not also a valid reason to choose. We'll take. Third criteria is the least required method. What the actual method we want. We could have been explained in the same case. The least square criterion minimizes the sum of the squares of the residentials in the model. Instead of epsilon I, if you take epsilon I square, sum of the squares, then it is a better tool. We'll see yi minus a naught minus a1 of x whole square, and summation if you take value of the yi minus a naught coefficient minus a1x whole square, to add some summation. How it will happen, we'll see that. Minimizing the sum of the squares of the residentials. This is a procedure. Our intention is to find the a0 and a1 by minimizing the residential with reference to a1 and a0. What will happen? Take a derivative of this residential del s over with reference to the first variable a0 is minus 2 times y1 a1, the same coefficient, that is equal to 0, or with reference to the a1, the same case, equal to 0. Remember, giving this, what it gives? Summation of a0 plus summation of a1 xi must be equal to summation of yi. This is the first derivative. Since a0 is the average of y value minus average of a1 times x, sigma a0 x, same here in this equation, plus sigma of a1 of x square is equal to sigma of y1 xi. Because of this, solve these two equations for a variable a0 and a1, which are depends on the x1. Okay, you will get a1 is the slope n times the sigma xi minus yi minus sigma xi and sigma yi over sigma xi square minus a sigma xi whole square, and a0 in different format. Remember, sigma times xi and yi, product of xi and yi under summation, differs from the summation of sigma xi and the sigma yi alone. In the sense, the product of sigma xi and the sigma yi differs from the summation of product of xi and yi. At the same time, the product summation is sigma xi differs from sigma xi square and minus sigma xi whole square. Okay, here n is the number of variables, number of observations. If you do like this, the torque, for example, another example, needed to turn the torsion spring of a mouse trap through an angle which is given in the table. Find the constants for the model where k1 plus k2 times theta. These are the values which if you plot. How one has to estimate? radians is there, theta, t is there. This is the given. Okay. T square you may estimate, T times T you estimate. We need this. And take the sum of all of them. This is the sigma T, sigma theta, sigma T, sigma theta square, sigma times, sigma of theta times T together. If you use this in equation for K2 and K1, where that K2 and K1 we have mentioned, K2 is the slope, K1 is the intercept. Y is equal to mx plus c of the form. These four values we need: sigma theta square, and sigma of theta times t. You will get this one K2 value. Another K1 you estimate. Use the average torque. Okay, K1 should be equal to say theta prime of this kind. Means K1 is equal to theta t prime of minus K2 theta. You'll get K1. Means if you plot, green are the observed values, blue is the line which is passing through the points, need not be exactly through. The blue line is the best fit line. Using linear regression, a trend line is found from the data. That is the line what we are expecting. You can find the spring of if it is a twisted from 180 degree, try. This is the one to find the longitudinal modulus of a composite of the following data which is collected. This is the equation sigma times E epsilon. Sigma is equal to E times epsilon, and the sum of the squares of the residentials they have given here. If we estimate for this formula, we continue. See, this is how you are getting. Just work out the examples. I will share the PPT today. This is with the Simpson's rule, least square fit method. Let us discuss the third method. Since you are already aware of these techniques, our interest is to have the programs. We need time for that. Okay. How that can be done? Numerical integration is nothing but the integration of any of the function numerically, not by the integral. Okay, means integration by the method of using the algebraic functions like summation. You will come to know at the end in such a way that numerical integration is the best tool to integrate any of the functions in any kind of a program. There are two techniques. One is the trapezoidal T, you can use as the uppercase also method, and another one is the Simpson's rule. Simpson worked out as fundamentally with one third rule, and updated or upgraded or revision of the first rule is known as the 3 by 8. How it works, we'll see. To have this, we need a basis of the Taylor series. How that Taylor series changes. You are well aware from your mathematics background, you are strong enough. That's why you scored more than 80% in your mathematics and maybe more than 80% in physics also in your graduation. Some examples of Taylor series which you must have seen are for different functions like cos x, 1 minus x squared by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial plus continuation. Sin x is equal to x minus x cube by alternatively between cos and sin. X cube minus 3 factorial x to the 5 by 5 factorial minus 6 to 7 by 7 factorial alternative positive and negative sign here. For example, e to the power of x is 1 plus x square by 2 factorial x cube by 3 factorial plus higher orders of higher terms. Means Taylor series general form goes in such a way f of x plus h new value at any interval. Assume that if we know the value of the function at x, if you want to estimate what must be the value of the function at x plus h, should be value of the function x at plus the value of the function at its derivative times h, the value of the function at its double derivative over 2 factorial times h square, the value of the function at third derivative over 3 factorial times h cube plus higher values. Provided that all derivatives of x are continuous and exist in the limit x and x plus h. If it is not happening, we are not supposed to put. Okay, means to say in English, plain English, this formula you can convert where Archimedes would have said, give me the value of a function, that is f of x, at a given single point, and the value of all its derivative, like first derivative, second derivative, and so on, at that single point, and I can give you the value of the function at any other point. That is a fine print expression in sense, not exactly the value, but it can follow the trend. Means if you know what must be the value of the function and what must be the value of its derivative at that point, then it is easier for us to estimate that what must be the value of the value or the position of the object at later stage. For example, if I know the position of the Earth today, if I know the position of the moon today, if I know the position of the Mars today, and their derivative, rate of change of speed, velocity, rate of change of velocity, or rate of change of how no displacement. Rate of change of displacement with time gives you the velocity. Okay, their velocities. If I know their position and velocities, I can at 2 points. If I know that for any two planets or any two celestial bodies, if I know their the position and velocities at 2 points, I can say that what must be their positions in future, whichever may be the amount of the time, maybe for next day or maybe for tomorrow or maybe day after tomorrow, after 10 years or even after 1 billion year provided, they have to behave in a similar way. They have to perform in the same fashion what it was functioned for their positions during their positions and during their derivatives. You'll see that. Uh, Find the value of the function. For example, if this is the case, f of 6, given that f of 4 we know, value of the function at the fourth interval we know, and their derivative also at the fourth interval we know, and their double derivative we know, their triple derivative we know, and all other higher order derivatives of f of x at x is equal to 4 are zeros. This they are negligible. If this is the case, how can an able to estimate without knowing the function? They will give in the tabular column value of the f of 4 125, value of f prime 4 74, value of f of triple 4 double derivative is 30, triple derivative is 6. What must be the value? We should know that f of x plus h is equal to f of x plus f prime x times h plus f prime double prime into x into s square by 2 factorial, so on and so forth according to the Taylor series. When x is equal to 4, h is equal to 6 minus 4, the interval step size is 2. Therefore, solution what will happen? F of 4 plus 2 is equal to f of 6. We'll get 341. Note that f of 6 is exactly, we only need to the value of the function and all its derivatives at some other point in this case. F of 6 is 364, what we got out of it. This differentiation is a continuous function. They will go with the forward difference approximations with f prime is equal to where the ratio of the value of the function at x plus delta x minus f of x over delta x within the limit where delta x tends to 0, with where delta x is a positive finite value. And if you take the derivative of that one, f prime x is approximately equal to f of x plus delta x minus f of x over delta x. We have not taken derivative. We have taken the values of the function and the value of the function at its new point and its displacement with time. If that is the case, here you know the x and you know the value of the function at the x. Okay, this is the value of the x, value of the x at function at the x, value of x plus delta x, and this is the value of the function x delta. If you know these two, apart from the function, draw a line between the 2 points, you will get a straight line and it looks like a trapezoid. That is why it is known as the trapezoidal rule. Sometimes If it is not curve, it may be a rectangle or maybe a square. That depends on the step size and also the curve. Graphical representation of forward difference approximation of first derivative. How it looks. Let's choose the example of a rocket. A velocity of a rocket is given by an expression v of t is equal to 2000 times ln of 14 to the power of 4, 10 to the power of 4 over 14 to the power of 4 minus 2100 times t minus 9.8 t within the interval between 0 to 30 seconds. After 30 seconds, it will function in a different way, or after 30 seconds, we don't know, or we don't have an expression, or this expression is valid for the interval between 0 to 30 seconds from its launch. Velocity should be in meter per second, time should be in seconds. Use the forward differentiation approximations for the first derivative of v of t to calculate the acceleration at 16 seconds. Use a step-sized interval of about 2 seconds. Find the exact value of the acceleration of the rocket and also calculate the absolute value relative to the true error from the spot. Acceleration is equal to difference in velocities at the two intervals over delta t. Ti is the initial 16 seconds. Delta t is the 2 seconds what they give. Ti plus 1 is equal to Ti plus delta t with 18. Acceleration at 16 is equal to v velocity at 18 seconds and velocity at 16 seconds over 2. If we estimate velocity at 18 from the formula, you will get about 450 meter per second. Velocity at 16 is about 392 meter per second. Hence, acceleration is the velocity difference delta v between these two over 2, about 30 meters per second. The exact value of 16 can be calculated by differentiating 2000 line over the values d by dt of v of t, d by dt of this 1 over t, d by dt of 1 over t is 1 over t square. If you estimate the acceleration between these two formulas, you will get about 29.67. If you estimate the absolute error, 29.67 over 30, earlier case, hardly 2.7%. If you continue with the backward difference method for this method, same case in a reverse order. X, instead of choose x and then go for xi minus delta x. How the solution can remain there is dealt by some example here. F of x is equal to 9 e to the power of 4x. F prime at 0.2 is backward substitution. Let us see. Interval is 0.05, 0.025, 0.025. Again, making half of this value at every step. This is the function value. This is the value how you are expecting. This is the error which is going down. Significant digits will happening up to third decimal at the last. This is the new value, estimated value, and this is the percentage. How it has to means to say, effect and step size in backward difference method makes sense. Even though number of steps increases, up to this extent fine. After 5 or 7 steps, even whatever with the number of step size, if you are increasing, the solution will not go any value. Means up to this is fine. Later it is remains constant. We can stop at any point about either 6th or 7th step at most actually. If it is with 0.95 with an approximate error method, error will come down from maximum this to coming down. They are anti-correlation. See that this is also error is coming down with approximate error. The effect of step size on least number of significant digits, if you correct, see that up to this digit, 1 digit, maybe 2 digits, maybe 3 digits. If you go with large number of digits, accuracy remains constant. This is a forward divide difference method they can call. Instead of that, f of x plus delta x minus f of x over delta x, if you take, this is the starting point for the function. Take the slope here. F of x is the value. F of x plus delta x, if you take another slope, how it has to happen, you have to see. See, it intersects like this. F prime is, this is the equation. And with this example, if you work out the velocity of a rock weight, with the earlier example for 16 seconds, at delta t is equal to 2. This is the two velocities. Substitute in the acceleration, you will get the acceleration of about 29.67 meter per second with an error of 2.693. how the trapezoidal rule will help actually here. Being this, by knowing that trapezoidal, we'll go with integration known as what kind of an integration? We need integration is nothing but integrating the function within the limit of upper and lower limit. Integration is a process of measuring the area under a function as a curve. See, this is between the function f of x. Okay. If we estimate the area under the curve between the limit a and b, a is the lower limit, b is the upper limit. Area under the curve or value of the area under the curve gives you the integral value. For example, if it is an x square over 2, okay, x square over 2 is the integral between 0 to 1, for example, means 1 square by 2 becomes 1 by 2 becomes half. Half is the integral of x square over 2 between the limit, half is the integral of the x between the limit a to b of 1 and 2, 0 to 1. Assume that this is the graph. F of x is the integrand they can call. A is the lower limit of integration, B is the upper limit of the integration. Trapezoidal rule is based on the Newton-Cotes formula that states that if one can approximate the integrand as the nth order polynomial like a Taylor series, if f of x into dx under the interval a to b is nothing but value of the function at x and is approximately equal to value of the function at nx. Means to say, if we expand the series, f of n of x is equal to a naught times 1 plus a1x plus a2x plus a3x to the power of a to the power of n a to the power of x to the power of 3. Being this, basis for the trapezoidal rule is that the integral of the first function is approximated by the integral of that nth order polynomial. Integral of f of x between the limit a to b must be equal to integral of the value of f of n at x, f of n of n x between the limit a to b. Means trapezoidal rule assumes that when n is equal to 1 here is the area under the linear polynomial, that is nothing but value of the f of x, integral of the value of the f of x into dx under the integral a to b is b minus a, the value of the function at a plus value of the function at b over 2, midpoint between these two over b minus a is the integral. This is the formula of the trapezoidal rule. The same thing we are applying for the derivatives. If you take the derivation of the trapezoidal rule, the area under the curve, trapezoid is a point, this is the value of the function and this is the value of the function. Connect these two functions by a straight line. Function may not meet actually. These are the 2 points which are essential to find the area for a trapezoid. Area of the f of x into dx within the limit a to b gives you the area of the trapezoid. Sum of the parallel sides, for example, here multiplied by the height and half of that value gives you the area from the trapezoid. Means 1 over 2 times value of the function at b and value of the function at a into the step size b minus a or a minus b difference gives you the value of the integral. B minus a over f of a plus f of b by 2 gives you the integral value. For example, how it works with the earlier problem, it shows the vertical distance covered by a rocket from 8th second to the 30th second is given by an expression. Earlier we took actually, use single segment trapezoidal rule to find the distance covered from 8th second to the 30th second, find the error and also an observed error. B minus a is about 30 minus 8, okay. F of a and f of b you have to estimate, okay. This is the f of t, this is f of 8 at point, f of 30 at point, this is the values. If you use this, the distance covered is 11 kilometer, the exact value of the above integral is 11.061. Exact value is so much, if you substitute into the formula you will get, otherwise 11.868. Between 868, around 800 meters is the difference from the method what you are getting. True value is 807, this is the difference. Error involved is about 7%. If you go for the double integral, multiple segment instead of one segment, you make it to the half of that value. See that 19 you get 487, accurate. Still if you go with the 205, error involved is less. See that so many multiple segments if you make, because somewhere it matches exactly. If that is the case, an integral I can be broken into the h integrals. a tied to a plus h to a plus 2h plus a plus n minus 2h to the a plus n minus 1h plus a plus times n minus 1 of h to the b. If we multiple segment, if you make like this, the applying this to the trapezoidal rule, b minus a over 2 times n, 2 times f of a, 2 times the sigma of f of a at a plus h minus, sorry, plus b. If you do like that, compared to the Simpsons, compared to the trapezoid, Simpson's one-third rule will come into the picture. There are two methods. The same case, there is no much difference between these two. Only the pressure I will explain. You have worked out all those things. It is only a recapitulation or memorizing or remembering the earlier formula and the processes and numerical techniques what you have worked out in your graduation in mathematics. This is the integral, similar to that of the trapezoid. Basis of one-third rule is that trapezoidal rule was based on the approximating the integrand by a first order polynomial and then integrand the polynomial in the interval of integrations. Simpson's one-third rule is an extension of the trapezoidal rule where integrand is approximated by a second order polynomial. A to b f of x into dx must be equal to f of 2 into x into dx. That is only two order polynomial. F of 2x is the second order polynomial. That is why if the function is that if you truncate it for the a0 plus a1x plus a2x square of that kind, it is a polynomial Taylor series. If you truncate it for a1x first order polynomial, if it is for a2x second order polynomial, if it is a third order polynomial a3x, if it is an nth order polynomial, it should be an of x to the power of n. If it is the second order, it should be f of 2. If it is third order, f of 3. If it is the nth order, f n of x. Okay. Value of the function at nth part means choose the basis here. A times f of a is at the initial point, f of a is the final point. A plus by 2 is the midpoint, and the value of the function at a plus b by 2, along with the value of the b, value of the function at b, and value of the function at f of b. These are the criteria. Means you need a and you need b. You need value of the function at a and you need the value of the function at b. And you need the midway between a plus b by 2 and the value of the function at a plus b by 2. 1, 2. See, 1, 2, 3 points, and their functions are those values are the criteria. As the 3-point method they can call here, that is one-third rule. 3 points of the function to evaluate the coefficients like a0, a1, and a2. F of a is equal to f of 2a, that's the value, a0 plus a1 times a plus a2 times a square. Our value of the function at a plus b by 2 is equal to f of f2 times a plus b over 2, a0 plus a1 times a plus b by plus 2 over plus a2 times a plus b by 2 whole square. F of b is that f of 2b, this is the extreme case, this is the lower limit, this is the upper limit of that kind, a0 plus a1b plus a2b square. This is lies with only constants, this also lies with constants, this also lies with constant. You know, you want to f of a plus b by 2 plus f of b at a point f of a, sorry, a and a plus b by 2 and b. If we estimate a0, a1, a2 with some coefficients, the same case, then you will go for the integral. The basic thing is that I is equal to f of f2 times x of dx, a0 plus a1x plus a2x square into dx, a0x plus a1 times x square by 2 after the integral plus a2 times x cube by 3 between the limit, a0 times b minus a plus a1 times b square minus a square over 2 plus b3 minus a3 by 2. If we solve this, you'll get b minus a times f of a and f of b plus 4 times f of a plus b by 2. This derivation is very, of course, otherwise, if you solve the function at any derivation point, these are the derivation. Means the step size is b minus a by 2. F of 2 is equal to, see that, this is b minus a is 3 by, h is b minus a by 2, h is here, b minus a by 2 or h you can choose, h by 3, f of a, value of the function at a, value of the function b, and 4 times value of the function at a plus b over 2. Because the above formula has an 1/3 in its formula, it is called Simpson's 1/3 rule. Or there are three concepts, value of the function at a, b, and 3-point method they are calling. That is the rule for that. If you solve the same equation instead of trapezoid from Simpson's one-third rule, how you are arriving for the answer or the solution? Just you check actually. You go through x is equal to f of t times dt. Okay, the limit t is equal to 80 to 30 seconds. This is the formula. We have to estimate the value of the function at 8, value of the function at 30, and value of the function at midpoint. A plus b by 2 is 8 plus 30, 38 by 2 is 90 times 4 value. This is 22 by 2. This is the value, this is the value, these are the values they are given. This is the 11.067 meter is the distance of distance. Okay. Sorry. The error involved is hardly 4%, 4.3 meters or about 0.3. Compared to that, Simpson's one-third rule makes the better tool for the estimating the or solving the integral equations. Like similar to that trapezoid, if you go for the multiple segment of one-third rule, fine. H is equal to b minus a by n. Take the interval between a and b. Value of the function should remain same between the two. Just like in multiple segment, one can divide the interval a to b into n segment in simply one-third rule repeatedly over every two segments. Note that n needs to be even here. Only criteria is that value of n should be even. Divide the interval AB into equal segments, hence the segment width is 7. Here, n value should be equal. Don't go for odd numbers, you should be an even number. That is the criteria. If you divide like this, every parallelogram becomes a trapezoid. Same case. This you work it out one day in a summation. How this example works with multiple. Use 4 segment instead of 3 segment for the one-third rule. Okay. Estimate. Instead of 30 minus 80 by 4, 5.5, f of t, f of 30, 1, 2. ft1, 8 plus 5.5, 13.5 plus 5.5, 19 plus 5.5. You got the values of the function at 13.5 values of the function, at 19 values of the function to 24.5. If you estimate with b minus a over 3n, you will get the value of this kind. Here 11.061 kilometer. Or if you estimate, the error has come down. Means to say, in the tabular column, the values of the Simpson's one-third rule, for example, in 2 with multiple segments, if you go, if the value of n is 2, approximate value is so much, error is 0.3. If it gets doubled, error has come down. At the 10th interval, if n is equal to 10 segments, if you make, okay, it becomes 11.1106.34 meter is the approximate value with the estimated accuracy of 0.00 here, okay, between these two, okay, and an error of 0%. Okay, this is the best method. I'll stop here for the Simpson's one-third rule. 3 by 8, you can work it out maybe in simpler way. Euler method I will take for the next class. Join with the same link by 12:15 to the Sushila madam. If you are having any doubts, I'm happy. Euler and Ranga Katta method I will take in the next class. First, I will unmute you all. Okay, you can unmute yourself if you want having any query. Stop sharing. Yeah, so many of you are there. Soumya, Chetan. Why Chetan has joined with 15 accounts? Sahana, Pooja, Shrikant, Monisha, Ramya, Kodan,